Hi, so today we're gonna do this question. Okay, so right now what it's asking is what is the output of a system if we give an input, and the question already gave us a frequency response. Okay, so usually from I think the first or second lecture, what we've found was that y of t, okay, which is the output of a system, is equal to the input convolved with the impulse response h of t, right? And so we've also learned in Fourier series that if we have let's say a function, right? So we have a function y of t right here, and if this function y of t is equal to the convolution of two other functions, right, then this implies that the Fourier transform of y, denoted by capital Y, okay, is equal to the Fourier transform of x, which is capital X, multiplied by the Fourier transform of the impulse response, so capital H j omega. So from this relationship, we get the formula y of t is equal to the sum from k equals to negative infinity to infinity a k, okay, multiplied by the frequency response, right? This is big H j omega, substitute j omega to k j k omega 0 multiplied by e to the power of j k omega 0 t. Okay, and so what ak is the Fourier coefficients, Fourier series coefficients of the input x of t, right, which has been given in the question. So we focus now first on the fundamental period. What is the fundamental period? So we have to find omega 0, right? This is the fundamental frequency. So we can find the fundamental frequency with the fundamental period. So 2 pi over t0. So this is 2 pi over 4. Pi over 2 radians per second. Okay, right. So all we have to do is just plug into this formula right here. This formula, just plug it in. Okay, so y of t is then equal to, what is k? So what are the values of k here? K, just look at this. The values of k are 0, plus minus 1, okay, and plus minus 3. And obviously the values for the Fourier series coefficients are 1, 2, and 4j. So when k is equal to 0, oops. So when k is equal to 0, we have 1 times e to the j k omega 0 t. So k is 0, so this whole thing is 0, this whole thing is 1. Oops. Okay, just 1. But the important thing is, what about the frequency response, right? So it's now j, okay, h of 0. Alright, so now what about k equals to 1? So k equals to 1, a1 is equal to 2. And what about this e here? Okay, so e to the 2j, yeah, 2j, no, k is equal to 1. So this is j omega 0 t multiplied by h of j omega 0. We do the same for the rest of the terms. So when a negative 1, so that's also equal to 2, multiplied by e to the negative j omega 0 t multiplied by h of minus j omega 0, because k is negative 1. And for 3, a3 is equal to a negative 3, which is equal to 4j. So 4j multiplied by e to the power of 3j omega 0 t multiplied by h j 3j omega 0, right? And for k equals to negative 3, it's 4j e to the power of negative 3j omega 0 t multiplied by h of negative 3j omega 0. Okay, so what do we find here, right? What this statement here means is we substitute omega as k omega 0, right? So we look at this one by one. So for this term, what is our omega 0? Is 0, right? So 0 is less than pi. So h of 0 is 1. 1, okay. Plus, okay. We look at this one again. So this is our, what is our omega? What is our omega? It's omega 0. So omega 0 is pi over 2, right? So pi over 2 is less than pi. Refer to this, right? So it's equal to 1. So 2e j pi t over 2. What about this, right? So the same thing. Why? Because it says here the modulus of omega. So what is our omega here? Negative omega 0, negative pi over 2, right? Which means that, you know, this negative pi over 2, this is less than or equal to pi, right? Because 0.5 is less than 1. So h here is 1. So same thing, 2 to the e minus j pi t over 2, right? So what about these two terms, right? They're actually trivial, because why? You see, h of j 3 omega 0, this is equal to h of 1.5 pi, right? Because pi over 2. What is 1.5? 1.5, yeah, that's not less than pi, okay? In fact, it's greater than. So this has to be equal to 0. Same thing with this one, h of j negative 3 omega 0. This is equal to h of j negative 1.5 pi, right? Because the modulus of negative 1.5 pi, okay, this is equal to 1.5 pi. This is already bigger than pi, so this is equal to 0. So we're left with the output of the system, which is this.